haven't really had chance to participate, but I'm working on some natural language processing and speech recognition for full time, and yeah, I would love to work on getting to know some papers and work on side projects on the side. So nice to meet you, Changhoon. Maybe I
could. Where are you from?
I'm currently based in Boston. I'm from Korea.
Cool. Nice to meet you. Yeah, it just helps with time zones.
Oh, I see.
People are
I'm popcorning off to Bishwa.
Hi, hello everyone. I'm Biswa. Currently, I'm doing my graduate program, Master's in Computer Science with specialization in AI. Besides that, I'm also working as a research assistant on the deep learning-based projects. This is my first meeting that I'm joining on NLP. Last week I was trying to join, but yeah, due to some reasons I could not join. So I'm excited to join this group and overall excited to learn from you all and share my knowledge as well. So yeah, thank you for this wonderful work.
Cool. And also, where are you from? Like, where are you?
Currently, I'm at Nebraska, Omaha, but I'm from Nepal.
Got it. Cool. Nice to meet you. Do you wanna
try?
Yeah, sure. Go ahead.
Okay. So I'm Noah Zeems. I'm a PhD student at Notre Dame, studying natural language processing under Meng Zheng. So yeah, finishing my first paper right now.
Cool.
Hi, everyone. I'm Akash. Yeah, go ahead. My name is Akash. I'm currently working as a research engineer here in Bangalore, India, and I mostly focus on NLP. Yeah.
Hi, I'm Kieran. I am a bit further afield. I'm a scientist and a physicist at CERN in Switzerland, where I currently am, and I'm just interested in AI and everything it is. So, hi, and looking forward to learning from all you guys.
Hello.
Hey everybody, I'm Xander. You can hear me, right?
Yep.
I'm a research engineer. Been doing deep learning work for about 7 years. I've been going to Roseanne's talks for quite a few years, but this isn't the first time. I just discovered the NLP group last week. So I'm based in New York City and really looking forward to these two papers.
Cool. Henry at Sushi, do you want to go quickly and then we can get started? Nice to meet you, Xander.
Yeah.
You're mute.
Okay. I'm Atsushi Saito, and I am working as machine learning engineer at Tokyo, Japan. So, thank you.
You're still on mute, Henry. You're muted.
Oh, muted?
Yeah.
So funny. I mean, I turned on the video and I forgot to turn on the audio. Just a click of the button. So my name is Henry. I'm based in Chicago. I'm an independent researcher. I'm interested in NLP, and right now I'm a business owner, but I'm searching for some interesting endeavor in the NLP field and see what I can do. Okay, thank you guys.
Okay, thank you. All right, thanks all for joining. Akash, I think since your presentation is RLHF is before InstructGPT, why don't you get us started and I'll follow up after.
Yeah, sure. Can you see my screen?
Yes, I can see your screen.
So what I had planned was I would briefly give an introduction about RLHF, and then I'll be covering this um repository which discusses the RLHF code. Mm, Okay, so let's start from the ChatGPT blog post. Um, where should I start from? Yeah, so to train ChatGPT, they use this method called RLHF. In basically what they do is they have two separate language models, and one language model generates an output, and another language model ranks those output, and it gives a scalar output which can be taken as a reward, and that reward can be used as a signal to be used via different RL algorithms to train the model using reinforcement learning. So yeah, so that is a very high level overview of RLHF. Um, so basically, if we look into this repo, so yeah, so as I said, there are two language models involved here. So first, you have to train the language model which generates the output sequences, and for that they are in this repository they are using Palm language model. So the idea is that you can use any language model here, and yeah, so first you have to train that language model that uh, generates the sequences from a given prompt. And then what you do is after that you have to train your reward model. So reward model is that whatever output that you get from the model that you just trained here, this particular language model, it will process those sequences, and yeah, to do that you have to train this model also. So you have very different ways to train this specific model. So I would refer to this blog post by from someone in Hugging Face, and in this they discuss like there are two different ways. So what OpenAI did to train their reward model was they used all the queries that they got for GPT-3 model, and they used them to train their reward model. And another company called, I think, Anthropic AI, they used Mechanical Turk to generate a separate prompt based data set which they can use to train their reward model. So yeah, so first you train your original language model, then you train your reward model, and then what you do is to um, put everything together. What you do is if we refer to this code, you pass both this model and the reward model to this particular trainer. And what it uses a PPO algorithm to train the entire setup. So just to give a brief idea about PPO algorithm. So PPO stands for proximal policy optimization. So it's an on policy RL algorithm, which basically means that it keeps improving its policy while it's interacting with the environment, and it does not use the saved past data. Or so in RL, the data that we use to train our models is basically a combination of action, states, observation, and the rewards that you got, and what was the log probability of those actions. So in an on policy RL algorithm, you are improving your policy. So policy is something which basically lets you to choose an action. So given an observation or a state space, so here in our algorithm, the state or the observation is the initial prompt that is given to the model. So let's say if you are giving any specific prompt like who is the president of United States, so that becomes the initial observation. of the model. And what then happens through policy is that you give output some actions. So here actions are basically the sequences that are generated by the by our language model. So in classic RL algorithm, if you're, let's say you're training anything, like if you have any experience of training anything in the gym environment, so there the observation or the state space could be something discrete values or continuous value, and actions is like what step should the agent take next. So here it's very important to realize that both the state space, sorry, the observation and the actions both are sequences. And yeah, so continuing about PPO algorithm. So PPO is an on-policy algorithm. It RL algorithm, so it improves its own policy. So here the policy basically refers to the probability distribution that the language model comes up with to output a particular sequence. So yeah, so the idea behind PPO is that you want your policy to change, not change drastically, because it's very easy for, let's say, if you're while learning the algorithm, it's very easy to take very huge steps from where your current um, uh, policy is. So the idea behind yeah, so the idea behind PPO is like you take the minimum step. Can you see this equation? Yeah. So the idea is that you take you clip the amount of change that you can do to your own policy while updating it. So here they have their custom this parameter that E. That makes that ensures that the policy does not jump too much. And what here, if you see that the pi here, in this part, if you see, like the pi theta is the current policy. So pi theta which gives an action given an observation S, state S, is the current policy, and in the denominator you have pi theta k, which is the old policy, which is the which in true it is the log probability of an action given a state. So yeah, so you multiply that with the advantage function for that particular state and action. So advantage function is the reward minus the value function, which is we don't really have to go into that much depth. So basically, PPO is an algorithm which ensures that while training our agent, we don't take very huge steps while updating our policy. So this particular repository also uses PPO RL algorithm. Any questions still here before we start discussing code?
I had one question for each of the for the new policy. How many samples is it taking? Does it have any number on like how many samples it requires to generate a new policy?
They have what they do is usually we'll see that. So after okay, I'll just show it. So what happens usually is that it will have its own number of episodes or epochs, like while training, like it will continue to keep doing so, like generating the outputs, and also, and after every update time step, which is something that you have to fix already, it it then learns that from the trajectories that it has till now. So they have this parameter like update time step, which ensures like how many samples it has to learn from. Yeah.
Okay. Is this like number of samples per input example, or is it just across all? Like, is it just one response per question, right, or per prompt? And there's some number of prompts that they do per policy.
Yeah. So yeah, for it, there'll be some total number of prompts which are fixed, and what they do is they generate the output sequences for those prompts, and then they rank those generated results through a reward model. And I think it is the number of prompts is actually fixed. So you can see here, like at any time they have a huge number of possible prompts. So at each time step they are in number, at each episode they're selecting a random number of random prompts, which is whose total number is decided by this particular variable. And in each episode they will take input of different prompts, and what they do is they will generate the states, action sequences, mask, all these things which are necessary for the RL algorithm to work. And yeah, so once this is done, and they keep repeating it for a certain time until they fill this memory, which is later used to update and learn the new policy for the agent.
Got it. So in the reward model, right, it has to take in both the human predicted as well as the generated text, right? I don't see that as inputs.
Yeah, so what they do is while training the reward model itself, they use the human input to train the reward model. So at runtime, when you're training the entire thing, you're not actually inputting the reward. You're not actually inputting the human input there. You just use that to train the reward model, and once that is done, you just use the reward model to get a scalar value for a reward.
Got it. Can you click into the reward model part? Can you go over that file a bit more?
Where is it? Here.
It's right there.
Yeah, so I'll just quickly discuss this trainer itself. So it'll be
Okay.
easier. So in this class, RLHF trainer, you basically have two things. So you have your actor critic. So in here, the actor is your PaLM, the original language model, which generates those sequences, and your critic is the reward model. And okay, so if I just show you this class, you'll understand. Yeah, here. So yeah, so here as an input, you basically have the PaLM, which becomes the actor language model, and the critic PaLM is your reward language model. So you basically in this class you define the entire agent with both the language models here. And yeah, here are some. And since both of these actor critics are trained on different using different things, so here you have different. So you might have different optimizer for which are parameters which are there in the actor and the parameters which are there in the critic. And they also use this Hugging Face Accelerate library to make it easier for them to train in a distributed setup. So if you see here, so what they do is when they initialize this trainer, what they do is that they then call this function train and the total number of episodes. So basically 50,000 times they will sample a number of prompts, randomly sample few prompts each time. And yeah, so what happens in the train function is for 50,000 episodes, at each time they will ask the actor critic to generate a sequence. So not a sequence, all these values which are important for the RL algorithm to work. We'll just see what these generate functions do. So if you go here, so yeah, so the generate function, what it does is, so first, so as I said earlier, actions here are basically the sequence, the output sequence that was generated by the language model given the input prompts. So what happens is that it gives the actor PaLM the initial prompts as the the prompts. So the state here basically refers to the prompt. So it gives states as the prompt input, and what we get is the actions, is the output sequence that is generated. And what happens then is that they basically concatenate both these state and actions. So the final sequence that you get is basically the combination of the prompt and the generated sequence. And later on, what they do is that they pass this to their forward function, this the entire sequence. And if you see in forward function, what happens is that they are actually sending this to the critic. And what that gives us is the embedding for the result, the embeddings for which we can later convert them into action logics and values, which are so action logics here basically gives us the sort of the probability distribution over over the generated sequence, as the reward model would have would think about it. And value here is basically the reward that you finally get. And so we were here.
Excuse me.
Yeah.
So is the state observation vector hidden states of the large language models? So my question is, what is so state observations vector?
Can you repeat? You are asking what are states and what are observations?
Yeah.
So yeah. So typically in RL algorithm, states are something which is the which is also referred as observation, which is the current input to the agent. So typically in RL, if you think of any RL agent playing game, so state or observation will be the vector that is representing the screen in some form. So here for our agent, state is the original prompt that was given as the input. Okay, because given input that prompt as an input, the model then generates an action, which is a sequence here. But typically in an RL agent, let's say, who's playing game, the action is like, which step should I take or which direction should I go to? But they're trying to combine these two words. So here the actions become the final output of the sequence of the model given those prompts.
So I guess so thank you.
Okay. Yeah, so we were here at generate. So yeah, once we get this action logics and the value, and basically value here is the reward that the critic model gives to the sequence that is generated by our original actor model. So yeah, once we have that, so this basically if you have
yes.
Sorry.
Okay, go ahead.
Yeah, so if you have experimented with any RL algorithm before, so this is what we save usually in our memory to be able for our model to learn. So yeah, so we save the state, the original input, the actions that the model took, the final output here. Sequence basically represents both the combination of state and action. And these are masks which we are used for calculating different things later. Action logics basically gives us the probability distribution of the sequence that is generated, but from the reward model, which is later used to calculate entropy, and value is the reward. So if you see here, they are saving this. Not here. Yeah. So once we do that, we get these values and we keep collecting them and storing them, yeah. So we keep storing them here in our memories as reward value and different things. And once we hit a certain number of update time step, what we do is learn from this memory And in the learn function, what typically happens is the entire PPO setup. So what they do is they create a data loader for all the memories that are stored till now, and then they put the actor critic in train. And what happens is that they basically train the model using PPO in this entire part here. So if you want, then I can go into the details of the PPO implementation here. But yeah, any questions till now? Conceptually, yeah.
This is a really great talk. Thanks very much. I was curious, just a conceptual question. Is there any reason to think that a RL model would be particularly good for as a language model? Sorry if that's a bit naive or not rightly formulated.
Yeah. What here the model is basically comprised of different language models, and they're using RL algorithms to train it. So basically, this entire thing becomes an RL model itself. But yeah, they're using the concepts from the RL world, and they're trying to apply them on the language model. Yeah. Does that make it clear for you?
No, I was just curious. Why would you even think about that from the beginning? Like, why
Yeah,
is it a good idea to use?
Because RL has been very good at, what the idea behind RLHF is, like, you want that you want the language model to inculcate the whatever response that humans are giving. That, let's say, if model is generating something, right, you want the humans or annotator some form of supervisory signal other than the cross entropy loss that is there already, which is used for training the language model. And one way to do that is, like, you train a reward model and using this human feedback, and whatever output this reward model does, then you can somehow use the human feedback along with the whatever the language model was already trained with, using RL algorithms. Because currently the RL algorithms are, especially like PPO, these are very robust enough to be used with language models now. So this is the main idea is that they should be able to use human feedback, and one way to use human feedback is through RLHF, which basically which uses an RL algorithm to include the human feedback here.
I think
Yeah,
the reason.
Sorry,
Go ahead. No, you.
Okay, I was just gonna say I'll go into this in like my presentation as well, but the main thing that I guess OpenAI is kind of getting at with these iterations is that they're trying to like work towards human alignment, right? So trying to get these models to align with human intent well, and that's like the main difference between InstructGPT and GPT-3 is that InstructGPT or this, which is trained using RLHF, is better at understanding what the human is asking, right? And the main way they're doing this is by like literally incorporating human feedback at every step, right? So like it generates output, you also have the human generated version, and the reward model kind of tells you, okay, the human prefers this one or the other one. So it will update the model, like fine tune it based off of human preferences. And that's like what they find, they say that fine tuning large pre-trained models based off of this approach to kind of teach it what human intent is, improves alignment. And alignment is what kind of makes these models more responsive to what we're saying and understand kind of human reasoning behind these questions. So I think at a very high level, that's why this was kind of, incorporated, is with the goal of better understanding human intent and incorporating feedback into the fine-tuning process in order to do that. And if you think about it that way, kind of having this RL approach is like very intuitive, right? Because you have like the existing policy, which is the supervised learning model. And then you have the new policy, which is the one that the human is kind of coming up with. And you're trying to improve your supervised learning model with like feedback at every step from the new policy, which is kind of designed by the human, which is the human intent.
Yes. All the while not forgetting what it originally learned while supervised training. So It
Yeah.
should not learn something entirely new, so that it just gives something from the human feedback and it starts outputting gibberish. So they have to maintain both things. Like it gives good enough output as well as which is takes the signal from the human input also.
That's awesome. That really clarifies it. Thank you very much for that.
The human feedback in this context, I mean, InstructGPT or ChatGPT, I think it's just human ranks the output of the generated from the supervised model, right?
There's
Yes.
actually a few things. They do rank it, but also in the beginning, they're actually writing their own responses.
Oh yeah, writing
Yeah.
the response, and I mean that's for training the SFT, right? And after that, then there's a ranking, right? I guess so far that's what I can think about as human feedback.
Yes. Yes.
Yeah. In
So-
in the yeah, we'll cover. I'll let Akash finish, and then I think some of these questions will also be answered.
But
on
one
that.
thing I'm thinking, I'm not sure whether that should be the way to do it. They collect prompt from OpenAI API. I think they do that, right? Like anyone can submit some instruction, right?
Yeah. So they mention here in this blog post also. So OpenAI used prompt submitted by user for GPT API, and answering for that. For ranking the test, there are multiple methods. So one is basically you can just give it a scalar value. So in this repository, they are just taking a scalar value, but they have mentioned that there is an ELO system also, that can be used to generate a ranking of models and outputs related to each other. So there are multiple ways to even how to even rank the answers that were generated by the reward model to be able to train it.
Okay, so suppose I'm a malicious guy. I want to do something bad. I can I just use the open, it doesn't mean I won't do it, but suppose there's malicious guy, he just abused the API and gives some very bad instruction pair. Is there any way to prevent from that?
No, not really. If you see a lot of people who are experimenting with ChatGPT, and they're sharing these images on their results on LinkedIn or on Twitter, they're showing that, let's say, an example that I just saw yesterday was they said that 33 plus 33 equals to 99. The model was they gave it wrong instruction and the model believed, okay, yeah. So then it just assumed that, okay, if the person is given this instruction, then it must be true, like 33 plus 33 should be 99 instead of 66. So that is the problem of that happening is there. But that's also possible. Yeah.
So you are saying they're not doing anything to prevent it. Whatever is submitted will be used for the training?
They have a lot of modules for safety, toxicity, harmfulness. Like there's a lot of things it's blocked from responding to. So that's like if you go through OpenAI's kind of documentation, that's definitely something they're working on. I mean, I don't think it's perfect yet, but yeah.
Okay. I hope that module can capture such bad things, I hope.
Yeah.
So
But yeah, I think the general way it's built is if it gives you an answer and you tell it is wrong, it will say, "Oh, I realize I made a mistake," and try to fix it, even if it's doing whatever is right. So they've trained it to kind of be very responsive, but yeah. Okay, cool. Do you want to keep going, Akash?
No, I guess that's it from my side. So at a very high level, we just discussed what the idea of RLHF is and how the code implementation is. We obviously didn't go into much depth, and maybe it'll get much more clear once we discuss InstructGPT.
I had a question. So if you were to actually run this, right, does it have a system in place? Like, does this repo have something in place for actually providing and taking in human inputs, or is that all provided as a data set? They kind of have human rankings already.
You already have data sets for RLHF, like one data set it mentioned in a blog post. You can use that, but problem for training that is not the code. In the repo also, the guy who wrote this mentioned that the problem is not the ship, it's the fuel or the amount or the money that you need for the compute to fuel that ship. So the code is there,
But you
but
can just do it with a smaller set of, it's just fine tuning, right? For this.
yeah, and that's actually
Can't you
something
do
I
it with
was
a
also
smaller set
thinking
of
about. Like, what
labels?
if we take a smaller language model and just test this and see what happens? That is something we can try, yeah, because the code is here already.
Yeah, no, I guess what my question is the data set that they provide, does it have all the rankings and all the human input? So you don't need to actually provide any human input.
I have not checked the data set, like what all that contains, but my assumption would be yes. Yeah.
Because I guess like a follow-up, right? If they've already trained it on that data set, what's the point of updating it, right? Like at some point, yeah. Anyway, I guess we only have 15 minutes for. Yeah, thanks, Akash. That was helpful. Any follow-up questions on his presentation? Okay.
Well, I mean, this this ChatGPT thing is really big right now. Can we spend, I mean, one half hour or 1 hour session won't be able to cover. It's only cover it, the tip of the iceberg. It's hard to cover really the essence of the whole thing. Can we spend more like weeks to cover this whole ecosystem of the ChatGPT, InstructGPT thing? Instead of just briefly, like just
Are
one.
there any specific follow-up areas okay, how about I go through my presentation first and then we can.
Okay, go ahead. Sorry, yeah.
Okay. So I'm kind of building on this a bit. So mine is more kind of answering some of the higher level questions everyone seemed to have. All right. Yeah, so as I mentioned, the main goal of InstructGPT as opposed to, for example, ChatGPT was that their goal is to make progress on aligning models that can act in accordance with human intention. And the focus is on fine-tuning approaches to aligning language models through RLHF. So they're kind of taking all of these supervised GPT models and just fine-tuning them based off of kind of what we just discussed in Akash's presentation. So they had kind of a team of contractors who both labeled data, wrote summaries, and then ranked them. Yeah, so they first collected this data set of human written demonstrations of the desired output behavior. And then the comparison, so comparing the human labeled output or the written summaries with the generated summaries or whatever task they were looking at. And then they trained the reward model on a data set to predict which model the labelers would prefer. And they used this reward model. This is summarizing what we just discussed, obviously. Use the reward model as a reward function to fine tune the supervised learning baseline to maximize reward using PPO. So yeah, this is, I think we already went over this, so I'll skip this. So these are the main contributions that they believe InstructGPT makes over the normal GPT model. Is one, yeah, labelers significantly, they use GPT-3 as the baseline essentially that they're comparing against, and they show that they also compared against FLAN and I think one or two other models. They prefer InstructGPT over GPT-3. There's improvements in truthfulness, toxicity. They also tried against various different NLP datasets. So the main one is against the open source data sets that people are putting up, right, for GPT-3 and InstructGPT. But they also train and evaluate this against public NLP data sets. They generalize preferences to held out labelers that did not produce any training data. So it's not overfit on the preferences or summaries or outputs of these people who are writing the data. Even other humans who did not come up with the training data set, when they were able to rank the candidates, it generalized to their opinions as well. And yeah, it's InstructGPT shows generalization to instructions outside of the RLHF fine-tuning distribution. We'll go over kind of what instructions they used in a bit, and the last one is, yeah, it still makes mistakes. I'm trying to put together a doc of like all the related work. I'll share this in the channel after. But the main areas this is kind of pulling from is alignment from human feedback. There's a lot of work on alignment. I think another team or group that's doing a lot of work on this is Illicit or OT. I've been going through kind of some of their work recently. Their approach to it is this thing called factored cognition, where they're trying to like break every task up into kind of small mini tasks and then see how well those can compose. So yeah, that's just one. I think there's a lot of different papers tackling how to better improve alignment based on human intent. And then training language models to follow instructions, evaluating the harms of language models, and modifying the behavior of language models to mitigate harms. Kind of all related to some of the questions on how they're kind of avoiding this to make mistakes or generate harmful content. So yeah, I'll put up this kind of from their related work in a bit. So the high level methodology obviously was first they collected the demonstration data. So this was like the human written outputs, and they trained the supervised model. Then they collect comparison data and train the reward model. And finally, they optimize the policy against the reward model using PPO. So yeah, humans are both writing summaries as well as ranking them after they're written. And the actual generated inputs are used for the supervised policy, and then the kind of labeling / ranking of the outputs is kind of used to train the reward model. And there's 3 kinds of prompts that are used for this. Plain human, you can come up with an arbitrary task. Few shot, which is multiple query response pairs per instruction. And then user-based is just things that people have asked for the OpenAI API to put out. So for the supervised fine-tuning, they fine-tuned GPT-3 on labeler demonstrations using supervised learning, trained it for 13 epochs using cosine learning rate and residual dropout. But what they found is like a major limitation of this is that they overfit on the validation loss after about 1 epoch. So this isn't like standalone. You can't just continuously do supervised fine tuning to kind of achieve the same results as what like the entire RLHF is able to do, because it overfits on these human demonstrations. So that's kind of why the reward modeling is so important. They start with the supervised fine tuning model with the final unembedding layer removed and train a model to take in a prompt and response and output a scalar reward. And then they present labelers with around 4 to 9 different responses to rank. And they train on all of these K-choose-2 comparisons from each prompt as a single batch element. Yeah, any questions about this? I think this is like a pretty important point, is that you can't just, like, I guess the other option is instead of doing this entire RLHF approach, why not just get a massive human labeler demonstration data set? But yeah, they show that this doesn't really actually improve the output very much.
I'm not sure if this is answerable, but do you know how much they spent on this human ranking component of it? Like, would anybody who isn't OpenAI be able to afford doing this, or is this a very restricted to a very scalable team?
Yeah, I think I had a number somewhere. I don't remember off the top of my head. They put up numbers on how many like petaflops per day they spend on this. I think I have that somewhere here. Yeah, here. Phew. Yeah, so they said that for this for the fine-tuning model, it requires 60 petaflops per day and is like 3,000, around 4,000 petaflops per day for training the GPT-3. So obviously none of us are training in terms of petaflops per day, but yeah, that's kind of how they referenced cost.
Okay. Is that, just to clarify, does that include the human mechanical Turk part of it, where humans are then giving different sentiments to rank?
Is your question specifically how much does it cost to have the 40 contractors write all of this data?
Yeah, effectively. I'm just wondering if that's an important part of it or not.
That is, but I don't think with respect to cost, it's the primary cost. Is my
Okay.
current understanding.
Awesome. Thank you.
Yeah, I think the compute is still more expensive, but I can double check. I don't think they put raw numbers in the paper at the very least.
Perfect. Thanks.
So this is the loss model for the reward function. Loss function for the reward model. So here, as you can see, r theta of x, y is generating the scalar output of the reward model for prompt x and completion y. YW is the preferred completion out of the pair YW and YL, and then D is the data set of comparisons. Yeah, so this is pretty much what the humans outputting is their preference between these different completions for a given input. So here's, yeah, the prompt X, and they have two different outputs, response W and response L. And then they're figuring out, this is kind of how they compute a reward function around that. And the K-choose2 is just based off of the number of different outputs that one of these labelers are presented with. So they're generally given between 4 and 9 responses to rank for each batch of training. Cool. And then, yeah, the RL model is fine-tuning the supervised fine-tuning model with PPO. The environment is a bandit environment which presents a random customer prompt and expects a response to the prompt. Given the prompt and response, it produces a reward determined by the reward model and ends the episode. And the per token KL penalty from the supervised fine-tuned model at each token is applied in order to mitigate over-optimization of the reward model. So this is generally how they kind of work this into PPO. Yeah, so I guess in this situation, every episode is one of these batches where a user or one of the labelers kind of decides one of the responses from the 4 to 9 on this batch of elements. And after you generate the reward, that is kind of the end of the episode, and it uses that to optimize the model at each step. The evaluation, so there are two main criteria. The first main one, so this was on the API distribution. So this is data that is generated through the ChatGPT interface, as well as the GPT-3, like the playground or all usages of the GPT-3 model by humans. So that's kind of what's pulling out all the prompts that they use for these evaluations. So the main metric is human preference ratings on a held out set of prompts from the same source as the training distribution. And they chose prompts equally between GPT and InstructGPT in order to not bias between the models, because they found that obviously humans are treating these models differently and figuring out what generates the best responses, with GPT not really having the same kind of prompting where it's like explain this way or more instruction based, whereas GPT isn't the same. So they kind of debias this by choosing equally between both. And then they also evaluate on public NLP data sets. So these are data sets with model safety, truthfulness, toxicity, and bias. So some charts, I think, on how to better understand the improvement from InstructGPT over GPT. So there are a few different graphs here. The first one on the bottom is how it is kind of performing on some of these subjective evaluations on preference. So they have hallucination count, uses language appropriate for customer assistant, explicit constraints, attempts, correct instruction, and they're comparing each of these different iterations. So GPT, the supervised fine-tuning model, the PPO with the supervised fine-tuning model, as well as PPO PTX, which they describe in the paper. It's like a small variant on the reward loss function. Yeah, and they show that that does like marginally better. It's not a huge difference. Yeah, so the metadata results on the API distribution due to dataset sizes, these results are collapsed across model sizes. Compared to GPT-3, the PPO models are more appropriate in the context of customer assistant, are better at following explicit constraints, and attempting the current instruction are less likely to hallucinate. So in general, they're able to show that doing this reward modeling improves each of these four criteria, which they are using as benchmarks to improve or measure human alignment. Yeah, and similar here. So the held out workers and training workers, this is essentially having the humans go in and label the responses. So held out workers are workers or labelers that did not actually provide their input into the supervised fine-tuning stage. So they're just there to kind of evaluate the output at the end. And the training workers are the ones that actually kind of generated that content. So they're able to show that even for the held out workers, most of the performance still holds, and it's an improvement over the normal GPT model. And win rate, yes, percentage of likes this model over the other model. Same thing here is just they looked at truthfulness for each one. And then this is kind of the cost of alignment research. So they said that increasing model alignment is relatively modest to pre-training, because as they show here, the cost for training the GPT-3 model was about 4,000 petaflops per day, but it was only 60 petaflops per day for the RLHF model for supervised fine-tuning, as well as kind of the reward modeling. For the 175 billion parameter model. And I think there's a similar number for the larger one. And they show that there's evidence that InstructGPT generalizes following instructions to settings without supervision, mitigate most of the performance degradations introduced by fine-tuning, and validate alignment techniques with real-world research. Cool. I think that's it for mine. Relatively shorter. Any questions?
Excuse me. How many the fine-tuned reinforcement running policy network parameters?
Sorry? How
As
many parameters does the fine-tune model have?
Yeah, is the 175 billion parameters updated in the?
Yeah, I don't think so, because as we mentioned here, they're removing the last layer. They start with this supervised fine-tuning model. They don't say exactly if they're fine-tuning the entire model or which layers they're freezing or not freezing. At least I don't remember seeing that. I don't believe they are updating the entire network in the supervised fine-tuning stage. Because if it was, I don't think it could overfit in one epoch.
Yeah.
Yeah, so I believe they I don't think they are. And then for the reward modeling, at the very least, they are taking that supervised fine-tuning one, removing the last layer, and then just iterating based off of the reward modeling. Yes, I don't have a direct answer to you. I can double check, but I don't remember the paper making it clear.
Yeah. So yeah.
At the very least, I don't think they are training it as long because, as they said, if you're only fine tuning it for one epoch, there's no way it's taking that much compute. Whereas like training the entire network and trying to get it to converge takes a lot more.
Okay. Gotcha.
Cool. Any other questions, comments? Henry, do you want to follow up on what you'd like to see if we were to revisit this? Or what do you think wasn't covered or you'd want to see more? I personally think a good follow-up would be for us to actually, I think Akash did a great job of walking through the code base, but if one of us were to actually try it out and, see if we can input our own data sets and see how that runs, that could be, a fun thing to do too.
Mute for a while.
Sorry?
I was mute for a while.
Oh,
Sorry, I muted myself. So, nothing in my mind right now. But if I think about it, it's just it's a heavy topic. It's like RLHF. The mechanism, how it works. Half hour is not going to be able to cover it, and unless we just. But because it's a paper reading group, we're not, maybe we just, different. We have a different mission than an educational thing, right? So maybe that's enough, but I don't know. It depends. Otherwise, it will. I would say I want to see more. Maybe not only me. Want to maybe see more details about how it works. So, in short, I think half hours, 30 minutes is too short for that heavy topic. That's what I'm thinking. Yeah.
sure, no worries. I mean, I think we spent the whole hour on it, but yeah, I think we can follow up on actually someone. I don't know. I'll see if I have time or someone else if they want to volunteer to actually try out the code base that Akash walked through and see if we can try out our own examples or what exactly the data set is providing. I think that will be like the last kind of more practical application since we kind of went through all the theory, went through the paper, as well as an overall walkthrough of the code base today. So,
Even if we do that,
sorry?
even if we do that, then someone will have to train that reward model, and we have no idea how to do that. Even if you want to try RLHF, first we'll have to train the reward model, and we don't know how yet.
I guess that's what does the data set that they provide actually have the labelers reward like ranking of the outputs, or do you have to provide that yourself?
Yeah, that's what we'll have to see.
Yeah, we can check. I mean, it wouldn't be that useful if they didn't provide that, right? Because at that point, you're asking everyone to come up with their own human annotation system. I know Hugging Face also. You pulled this from Hugging Face, right? The code base.
The code base, no, it's some guy, Lucid Rains. He is a very prolific writer for ML code.
Okay,
So,
got it. I see. Because I think Hugging Face also has one up, and I think they might have one of those spaces thing. We can look into it. That might be a good thing to check.
Yeah. But if it would be very interesting if we can do the same thing on using smaller data sets, if it's possible.
Yeah, sounds good. Okay, cool. So any papers people want to add to the backlog for next week? We can also look into kind of running through this demo. Yeah, and maybe for next week, Noah, do you think you'll be ready for presenting? Or I can try to present one of the kind of more projects I've been working on for the test generator.
Let me ask my advisor if I'm allowed to talk about it publicly. I guess this isn't technically publicly, but I have to double check.
Yeah, for sure.
Is anyone
Okay.
a reviewer for ACL here? Okay, sounds good. Probably he'll be fine with it, but I have to double check.